Hello everyone, we are back with our second video, Basic Mathematics. Why we are studying Basic Mathematics? Because in my last 6 months, what I have seen, the students are completely weak in Basic Mathematics. So to go further ahead in the further topic, Basic Mathematics is the most required topic. So in this video lecture, we will cover Basic Mathematics Part 1. Guys, we have divided Basic Mathematics into 3 parts. First part is Basic Mathematics 1, second part is Basic Mathematics 2, and third part is Basic Mathematics 3. First part of Basic Mathematics will cover number system, Pythagoras Theorem, Algebraic Formula, Law of Exponent. Second part of Basic Mathematics will cover decimal, basic definition, board mass, componendo and dividendo, and Basic Mathematics 3 will cover the remaining topic. So we will start with Basic Mathematics 1, that is number system. So let's start with number system. In number system, we are going to study natural number, whole number, rational number, irrational number, integer, and their notation. So we will start with number system. So let's start. In number system, first we will study natural number. So we are starting with natural number. Natural number is denoted by n. And then what is natural number? Suppose if someone asks you to start counting the number, we start with 1, 2, 3, 4 and goes up to infinity. So natural number starts with 1, 2, 3, means natural numbers are the counting numbers. So natural numbers are the counting number. Now if it is a counting number, we will start with 1, 2, 3 and we will go till infinity. So natural number starts with 1, 2, 3, 4, 5, 6, 7 and goes up to infinity. Second part is in number system is whole number. What is whole number? Whole number is denoted by W. Whole number is denoted by W. It starts with 0, 1, 2, 3, means all counting number including 0 is called a whole number. So this is 0 plus all counting number. So example of this whole number will be 0, it will start with 0 and will go till infinity. So 0, 1, 2, 3 till infinity. Third part is integer. Integer is denoted by Z. So we will denote integer by Z. Now what is integer? So integer will define as all counting numbers including 0 as well as negative of counting number, means all counting number plus 0 plus negative of counting number. In counting number, as we know from natural number, it starts with 1, goes to infinity. So integer, this will be 1, 2, 3, 4 till infinity. including 0, so we will include 0, and negative of natural number. So we will take negative of natural number. Negative of natural number will be 1, means negative of natural number is -1. If natural number is 2, negative of natural number will be -2. Similarly, -3 till -infinity. So in integer, what we have seen is this part of the integer is positive. If this part of the integer is positive, we will denote it by z plus. And this part of the integer is negative, so we will denote it as z minus. Now we will move to rational number. Fourth part of this number system is rational number. Now what is rational number? A number which is in the form of p by q. I will explain what is the meaning of p by q. So rational number is a number which is in the form of p by q, where q is not equal to 0 and p and q both should be integer. So p and q are both integer. Now what is the meaning of p by q? P by q is the representation of a fraction. Like if we take a number 5, we can write 5 as a 5 by 1. So we can write 5 by 1. So we represented 5 in the form of 5 by 1. In this, 5 is a numerator and 1 is a denominator. So 1 is denominator. 5 by 1 represents p by q, meaning p by q, 5 by 1 is in the form of p by q. So here if we take p value, we will get p value 5 and q value 1. Now we will check which number will be called as a rational number and which will not. So let's start with example. Suppose if you are taking 0. What is 0? Is 0 a rational number or is 0 a irrational number? How we will know? So to know whether 0 is a rational number or not, we will see if 0 can be represented in the form of p by q or not. If we are able to represent 0 in the form of p by q, so means this condition will be satisfied. So we can write 0 as 0 by 1. So first condition is satisfied. Second condition for rational number is q should not be equal to 0. Now here q value is 1. Q should not be equal to 0, so this condition is also satisfied. Now p and q both should be integer. So p and q both should be integer. So in this case, as we know, integer is all counting number including 0 and all negative of the counting number. So here it is 0, so 0 is an integer. Now if you see 1, 1 is also a integer. So 1 is also a integer. So means p and q both are integer, means p and q, this condition is also satisfied. Meaning for a number to be a rational, these three conditions should be satisfied. So we are done with this. Means 0 by 1 means it satisfied this condition as well as this condition, meaning this is a rational number. Now we will see another example. Suppose we are taking root 2. Can we represent root 2 in the form of p by q? Yes, we can represent root 2 in the form of p by q. Root 2 can be written as root 2 by 1. Is 1 not q should not be equal to 0. So it is 1, meaning this condition is also satisfied. This is satisfied, first condition is satisfied, second condition is satisfied. Now we have to go on the third condition. P and Q both should be integer. Here, as we know, 1 is a counting number, so it is a integer. But root 2 is not an integer because root 2 doesn't come in counting number as well as negative of counting number and 0. So this is not integer. If this is not integer, then P and Q both are not integer. Means P is not an integer, Q is integer. So this condition is not satisfied for this case. Meaning this is not a rational number. Another definition of rational number is rational number should be a terminating decimal or a recurring decimal. Means it should be terminating one is terminating decimal. We will deal with the decimal in our basic mathematics too. Terminating decimal means, example, suppose if it is 4.05, means that after two places of decimal it terminates, so it is called terminating decimal. So terminating decimal comes under rational number. So all terminating decimals are rational number. Second is if the decimal is of recurring or repeating type or repeating decimal, we will call such decimal as a rational number. Why we will deal these things in a real number topic which will come ahead. So recurring or repeating decimal. Suppose let's take example. Recurring or repeating decimal. If we take 4.56 bar, suppose 4.6 bar. What is the meaning of this bar? This bar means 4.56. This 5-6 will go on repeating. So 5-6, 5-6, 5-6, like it will go. So if you come across such type of example or such type of number, meaning this recurring or repeating decimal will be our rational number. Means we can convert this decimal into a rational number. So if the decimal is of type terminating or recurring, this comes under rational number. Now we will deal with irrational number. What is irrational number? Fifth part is irrational number. Irrational number. Now what is irrational number? As we have seen in rational number that terminating and recurring decimal are the rational number, means which we can convert that decimal into a rational number. Now irrational number, if we see, is if the decimal is of the type non-repeating or non-recurring, non-repeating or non-recurring. If we look at the example, like this type of decimal, if we see 5-6 is getting repeated here, but here no one was there. Now here one comes, double one, means after decimal this part is not repeating, so we'll call this decimal as a non-repeating or non-recurring decimal. Next is non-terminating. What is the meaning of non-terminating? Which doesn't terminate, which do not terminate. Like similar example, if we take like 3.21467, 8, it goes on means it further goes on, so it doesn't end. Means such type of decimal which do not end is called non-terminating decimal. So we are done with our number system. And one more thing, rational number and irrational number together forms a part of real number. Means in real number both of them comes, like it is a rational number and it is irrational number. So first part of the basic mathematics 1 is done, number system. We will move on to the second part, that is Pythagoras Theorem. So we will see Pythagoras Theorem now. Pythagoras Theorem. When I was teaching in one of the coaching center, this is the topic you have to study in class 8 in CBSE board. When I was teaching in one of the coaching, what I saw that student of class 10th was unaware of this topic. So I found this topic should be included in the basic mathematics, so I am going to teach this topic in basic mathematics 1. So be careful and study this topic carefully. Pythagoras Theorem. What is Pythagoras Theorem? Before studying Pythagoras Theorem, I would like to tell you this Pythagoras Theorem we can apply in a right angle triangle. What is right angle triangle? Triangle is a figure bounded by three sides in which one of the angle is 90 degree. So suppose name it, if it is A, it is B, it is C. Now Pythagoras Theorem we can apply in right angle triangle. What is, we have to identify which one is P, which one is B, which one is H. P stands for perpendicular, B stands for base, and H stands for hypotenuse. So first we will identify which side of a triangle is hypotenuse. Guys, it's very easy to analyze this thing. See, it is a right angle of the triangle. The opposite side of this right angle is called hypotenuse. This is hypotenuse. Second, we have to identify between P and B. No matter if you take this as P, it is also okay. If you are taking this as P, you can take this as B. Or you can take this one as P or this one is B. Now, what Pythagoras Theorem states is that in a right angle triangle, P squared plus B squared is equal to H squared. Or we can write H squared is equal to P squared plus B squared. Now, if you want to remove this square, you can put under root over this thing, so it will become H is equal to root over P squared plus B squared. So, what is Pythagoras Theorem? Pythagoras Theorem, first of all, we can apply this in only right angle triangle. This is the first condition. Second, if it is a right angle triangle, then the Pythagoras Theorem states that P squared means perpendicular squared plus square of base is equal to the square of hypotenuse. So guys, this was Pythagoras Theorem. And I would like to tell one thing, when I was teaching on the coaching, students has remembered that AC squared is equal to AB squared plus BC squared. See, if you are naming this triangle like ABC, then this thing is correct. But if you are changing the order of naming, like if you are taking this side, this corner as B and this vertex as C, then the Pythagoras Theorem becomes wrong. So it's very simple to analyze. First you identify which one is hypotenuse, which one is perpendicular, which one is base, then apply the Pythagoras theorem. Don't use this technique. Now we will deal with the third part, that is algebraic formulas. First we will study a plus b whole square, where a is a variable, b is a variable. We can replace this a by x, y, any variable, m, n. So a plus b whole square we can write as a plus b into a plus b. Like x squared is written as x into x. Similarly, a plus b whole square can be written as a plus b into a plus b. Now, this a will be multiplied by whole a plus b, so we will write a into a plus b, plus this b will get multiplied by whole a plus b, so we will write b a plus b. A multiplied by a is a squared, a multiplied by b is ab, b multiplied by a is ba, b multiplied by b is b squared. Now ab ba, from commutative law of multiplication we know ab is equal to ba. Like if we take a value 3 and b value a value 2 and b value 3, we can write ab as 2 into 3, which is 6. Now ba, 3 multiplied by 2, so we will get 6. So from here we can say ab is equal to ba. So this can be written as a squared plus ab plus this ba can be written as ab is equal to ba plus b squared. Now a squared, ab plus ab is 2ab plus b squared. So a plus b whole squared is a squared plus 2ab plus b squared. This is the proof of a plus b whole square. How we will derive? This is the procedure. Similarly, I will write the formula. You have to derive on your own. And if you are unable to derive this formula, like a minus b whole square formula, just mail me. I will send you the copy. I will send you the notes by writing the solution of this a minus b whole square and other formula. Now we will deal with a minus b whole square. I am just simply writing the formula. A minus b whole square is a square minus 2ab plus b square. Third, a square plus b square, we can write it as a plus b whole square minus 2ab. How? See, a plus b whole square, as we have seen, we can write as a plus a square plus 2ab plus b square, and this minus 2ab. Plus 2ab minus 2ab will get cancelled. We are left with a square plus b square. So we can write a square plus b square as a plus b whole square minus 2ab. Similarly, a plus b whole square, a square plus b square whole a square plus b square can be written as a minus b whole square plus 2ab. Next formula is a plus b, a square minus b square. A square minus b square, we can write it as a plus b into a minus b. Next formula is a plus b whole cube. We can write it as a cube plus b cube plus 3ab a plus b, or a cube plus b cube, or you can just expand it like 3ab into a is 3a square b plus 3ab into b is 3ab square. So now we will see a minus b whole cube. A minus b whole cube can be written as a cube minus b cube minus 3ab a minus b. We can write it as a cube minus b cube minus 3a squared b plus 3ab squared. Next formula is a cube minus b cube. A cube minus b cube we can write as a minus b into a squared plus b squared plus ab. You have to keep in mind that if it is a cube minus b cube, you have to take here plus ab. Now next formula, a cube plus b cube, that is it will be a plus b into a squared plus b squared minus ab. If it is a cube minus b cube, we have to take a squared plus b squared minus ab. But if it is a cube minus b cube, we have to take plus ab. Next formula we will take 10th one. It is a plus b plus c whole square. A plus b plus c whole square we can write it as a squared plus b squared plus c squared plus 2 into ab plus bc plus ca, or a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. So these 10 formulas are the most basic formulas in the algebraic formulas which we are studying, the basic mathematics. So just remember all these 10 formula. This will help you a lot. Next subtopic in basic mathematics 1 is law of exponent. We will study law of exponent. This is the last subtopic in basic mathematics 1. So fourth topic is law of exponent. In law of exponent we will study 4 different laws. Like first we will study what is x to the power 0. Guys, this question is very common. What is x to the power 0? You will see most of you will fail to answer this question correctly. Like I will tell you, x to the power 0 is 1. Here you can take x value anything. I say 1, 2, 3, 4, minus 1, anything. Except x should not be equal to 0. If x is equal to 0, 0 to the power 0 becomes undefined. So if anyone asks you what is x to the power 0, you have to answer x to the power 0 is 1. Like anyone can ask you what is 10 to the power 0? 10 to the power 0 is 1. What is minus 13 to the power 0? Is 1. So anything to the power 0 is 1 except x should not be equal to 0. If x is equal to 0, 0 to the power 0 becomes undefined. This is most important thing. Second we will study if the given expression is 1 by x to the power a. 1 by x to the power a, we can write it as x to the power minus a. Means if you are taking this x to numerator or from denominator to the numerator, the positive power becomes negative. Means 1 by x to the power a can be written as 1 by x to the power minus a. Third law is that x to the power a into x to the power b can be written as x to the power a plus b. Meaning if the bases are same, then the powers can be added. Here our base is x and powers are a and b. So keeping the base same, the powers will get added. So x to the power a plus b. Now we have fourth law, that is x to the power a by x to the power b can be written as x to the power a minus b. Now what we have seen in the second law, that 1 by x to the power a can be written as x to the power minus a. Similarly, we can write this expression as x to the power a into 1 by x to the power b, which can be written as x to the power a into x to the power minus b. Now applying the third law, we will get, if the bases are same, then the powers are get added, so we can write it as x to the power a plus of minus b. As we know, plus into minus is minus, so we'll write x to the power a minus b. So we have covered the basic mathematics part 1 in this lecture. Our second lecture for basic mathematics 2 part 2 will come after 2 or 3 days. 9th is a complete platform to learn, but 10th will not give you a chance. So subscribe our channel and give us support